Okay, let's dive right into this explainer. We're looking at something absolutely mind-blowing today, the architectural foundations of the quantum vacuum. You guys already follow quantum mechanics, so you know we're zooming past the whiteboard theories and actually building these physical systems. But to really get how these next-gen machines work, we've got to completely flip our perspective on the canvas they're built on. We're not just upgrading a CPU here, we are literally manipulating the underlying fabric of existence.
Which brings us to a massive, profound paradox. Is an empty void actually empty? I mean, when we look out into the absolute darkest, most isolated pockets of deep space, or even peer down into the tiny gaps between atomic particles, our gut instinct says, well, there's nothing there, right? Just empty space. But as we'll see today, that intuitive assumption, that is actually the biggest roadblock to understanding how quantum computing really works.
So, let's kick things off with Section 1, the myth of empty space.
The absolute most crucial thing to grasp here is that the vacuum of space isn't just some blank, empty room. It actually possesses a dynamic, physical architecture. Think of it more like a tightly woven tapestry. It has geometry. It has rules. Quantum computing doesn't just happen to sit inside a vacuum. It actively exploits this hidden, structural foundation. It's essentially using the invisible scaffolding of the universe to do the heavy lifting of computation. Crazy, right?
Moving right along to Section 2, bits versus qubits.
Now think about how rigid and locked-in classical bits are compared to qubits. Those traditional ones and zeros, the exact same ones running the device you're watching this on right now, are physically trapped in strictly defined states. They're basically on or off, right? But a qubit? A qubit plays on a completely different dimensional field. It doesn't just sit there in a locked state. It actually reaches out and taps directly into that quantum vacuum itself.
And this definition really changes everything. The quantum vacuum isn't an empty void at all. It's an expansive, hyperactive sea just bustling with fluctuations and entanglement. It's this incredibly dense field where particles are literally popping in and out of existence all the time, creating these constant microscopic ripples. Plus, through entanglement, these elements share information instantaneously across the entire field. This is the exact architecture the qubit is plugging into. It's not sitting in the dark. It's hooked up to a vast, buzzing, interconnected power grid.
All right, let's look at Section 3, freezing the noise.
So to actually harness this incredibly delicate field, we have to completely control the environment. We do this by chilling it down to near absolute zero. Why? Well, if the quantum vacuum is this subtle, buzzing field of tiny fluctuations, literally any outside energy is going to completely drown it out. Heat is essentially just atomic vibration, which means heat is noise. To hear the quiet, subtle whispers of the quantum vacuum, we drop the temperature to near absolute zero. We are effectively freezing out the loud, chaotic, classical noise of our everyday physical world.
And that freeze brings us to this beautiful state called coherence. Coherence is that perfect, incredibly fragile, suspended condition required for the magic of the quantum vacuum to actually perform calculations. It's when the qubit successfully syncs up with the vacuum's fluctuations. Down at near absolute zero, the everyday physical world basically steps back, allowing the vacuum properties to step forward and completely take over the system. We have officially cleared the stage.
Which leads us perfectly into Section 4, the power of interference.
Okay, let's walk through the actual mechanical steps where the vacuum starts acting like a physical machine, using interference to sort the truth from the noise. First, like we just talked about, we suppress that classical noise. Second, with all that noise gone, we let the vacuum's natural properties perform interference. You see, in the quantum realm, probabilities interact a lot like ripples overlapping on a pond. And here is where the computation itself actually happens, steps 3 and 4. Through this vacuum interference, the system naturally amplifies the correct mathematical answers, while at the exact same time, it cancels out the incorrect ones. It computes by letting the architecture of the vacuum filter out the wrong possibilities, leaving you with only the truth.
Now, I know a lot of this sounds like something straight out of a sci-fi movie, but it is grounded in highly advanced real-world physics. To really dig into the physical realizability of this architecture, you gotta look at the hard data. This is exactly where you can jump into the source panel to gather specific reference materials and hit up the deep research tool to pull the actual academic papers. It completely bridges that gap between theoretical awe and physical reality by directly linking us to the hardcore science of vacuum fluctuations and qubit coherence. It's how we ground this wild, mind-bending theory into fact.
Since we really only just scratched the surface of mapping this architecture, I gotta ask, are you ready to launch a deep research session into the bustling machinery of nothingness? We've just seen that the void might actually be the ultimate computational engine. So are you ready to stop looking at space as just an empty container and start exploring it as the ultimate operating system?